Let's discuss a question from thermodynamics. This is a question on ideal gas, basically on air. So 0.75 kg of air has a pressure of 4 bar and temperature is given. So it undergoes a constant volume process. So in the PV diagram it looks something like this. Constant volume process, vertical line. So heat is added, so that's why we have turned vertically upwards, because the pressure will increase. Okay, this is 1 and this is 2. Okay, so now applying the first law of thermodynamics, dq is du plus dw. So this is given as 1000 kilojoules. Work done is 0 because it's a constant volume process. Now du for any ideal gas is mCv delta T. Okay, and this is 1000. In any process, irrespective of the process, the change in energy for ideal gas is mCv delta T. So m is 0.75 and Cv is 0.707 kilojoules. Delta T is the T2 we don't know, T2 minus T1, and T1 is basically 130. So 130. Okay, so from this, if we calculate, T2 comes out to be 2015.9. okay, so that is T2 degrees Celsius. Now final pressure is asked. So if it's PV is equal to MRT is the ideal gas equation. Now volume is constant, everything else is constant, so P2 by P1 is nothing but T2 by T1. And remember that here temperature means in Kelvin, right? So P2 here would be P1 into T2 by T1. So P1 is given as 4 bar. Let's look at it here. So 4 bar, and T2 is basically 2015 degrees Celsius, so you have to use Kelvin, so plus 270. Remember, this is the gas thing. If you take ratios in Celsius, you will get the wrong answer. It's basically Kelvin. Okay, in ideal gas, whenever you're using ideal gas equation, remember that T has to be in Kelvin. Okay, and T1 is 130, so 130 plus 273. So if you take the ratio and find out the pressure, it comes out to be 22.64 bar. 22.64 bar is the final pressure in this 22.64. So this is a very simple problem. Thank you.